right, Algebra 2, we have 7.3 today, Logs Day 1. Logarithms, or logs, are the inverses of exponential equations. If y equals b to the x, that's our exponential equation, then in log form, x is log base b of y. So the answer to a log is the exponent. Okay, and the log base b is the same as our big base b over here. It's just that the base is now a subscript. And then the answer to our exponential is now part of the log, the big part of the log. So really the x and the y just flip-flop spots. The base b is still the base. If you think that's confusing, don't worry. It gets easier with actual numbers. 8 equals 2 to the third power. So the answer to a log is an exponent. So 3 equals log base 2 of 8. All right, I like to write it with the answer on the left and the log part on the right, because then you can do this little saying. This is how I kind of walk through it in my head, especially the first several times every year until it kind of gets more familiar and comes back to me. X equals log base 2 of 8. X is the power of 2, that gives me 8, or that equals 8. X is the power of 2 that equals 8. X equals log base 2 of 8. So what power of 2 gives me 8? 3. So x is 3. 3 is the exponent is the answer. All right, take it easy. Don't hurt yourself. Let's try rewriting these logs in exponential form. Okay? I'll do the first one here with you, and then we'll push pause, and you can try to rewrite them. Maybe I'll do the first two, because this side it looks like I turned it around. Okay? 2 equals log base 4 of 16. So 2 is the power of 4 that equals 16. So 2 is the power of 4. 4 to the second power equals 16. Okay, this one's the other way around. This is how you're probably going to see it in the book, or maybe on your worksheet. All right, so you can either try reading it backwards, or if you need to rewrite it. So this 3 is over here. 3 equals log base 3 of 27. You could do that. Okay, and after you get used to doing it this way enough, then this way isn't as intimidating. You can kind of read it backwards, and pretty soon you'll just be able to look at it and know. Okay? 3 is the power of 3 that gives me 27. So 3 to the third equals 27. 3 is the power of 3 that gives me 27. All right, go ahead and push pause, and you try the rest of them here. Okay. This one might have been a little confusing because you're like 64, that's 8 squared. You're thinking this should have been an 8. Turn it around. We're doing 6 is the power of 2 that equals 64. 2 to the 6th is 64. Remember, the answer should be the exponent on top of our base number. So the answer is the exponent on top of our base number. 4 to the negative third. Okay, 4 to the third power is 64. 4 to the negative third power is 1 over 64. We've been working on those negative exponents and how they're the same thing as the positive exponents, but just flipped upside down. All right, rewrite each exponential equation in log form. In log form, okay? So 15 to the third power equals 3,375. Remember, the exponent is the answer to a log. So 3 is the power of 15. So log base 15. That equals 1,375. So the answer, the exponent is the answer. 3 equals, same base number, log base 4 of 64. Okay, should we do one more? Let's do one more. Let's do the fraction one. The exponent is the answer. The exponent is the answer. 1/3 equals log base, same base. This is the base of the exponent, so this is going to be the base of the log. 125 of 5. Okay, go ahead and push pause and give these a shot. All right, so here we go. Exponent is the answer. 5 equals log base 2 of 32. 5 is the power of 2. That gets me to 32. Okay, the exponent is the answer. 1/4 equals log base 81 of 3. All right, next type of problem is evaluate. Evaluate. And sometimes they'll give you like an x or equals or a y equals. Sometimes they won't. Like this one, log base 16 of 4. Evaluate. What I like to do then is just throw an x or a y over here, because that's what you're trying to find. You're trying to find the answer to this. The answer is unknown. We're trying to find the answer. So I'll throw a x equals over here or a y equals, and then I can kind of mentally walk through it like this. Y is the power of 16 that equals 4. 16 to the y equals 4. Then you might be able to look at it and figure it out, or we can use our strategies from last class where we rewrite each side as a 4 and see how we can do that. Okay, and it's going to be a half. The answer is going to end up being a half, because a half power or a half exponent is the same as a square root. So 16 to the 1/2, or the square root of 16, should be 4. Okay, I'm going to throw down an x over here. X equals log base 3 of 81. What is the power of 3 that gives me 81? 3 to the x equals 81. Okay, you might be able to look at it and know. Okay, what power of 3? 3 times 3 is 9, times 3 is 27, times 3 the 4th time is 81, so it's going to be 4. Or maybe you want to rewrite it like we were doing the other day. I know 81 is 3 to the 4th, and there we have x and 4. Let's try another one. Y equals, or x or z or whatever, log base 1/5 of 25. So y is the exponent of 1/5 that gives me 25. So we got 1/5 to the y power equals 25. Okay, maybe we want to rewrite these both as 5s. So 5 to the -1 with y. 25 is 5 squared. So when we have power, parentheses power, we multiply. So we're going to have 5 to the -y power equals 5 to the 2nd. So we have -y equals 2. Or positive y equals -2. Okay, let's have you try the other two over there on your own. All right, so I'm just going to throw an x down here. X is the power of 6. 6 to the x equals 216. So you can just use your fingers or your calculator here. 6 to the first power is 6. 6 to the second power, 6 times 6 is 36. Times 6 again to the third power, 216. Okay, tricky one over here. What is the power of 1/3? So 1/3 to the x equals 1/81. Okay, these are both upside down. We can make them both be 3's. So 3 to the negative 1. X equals, let's see, 3, 9, 27, 81. So it's going to be 3 to the 4th, but it was upside down. So 3 to the negative 4th. And we're going to have negative 1 times x. So negative x equals negative 4. Positive x equals positive 4. Okay, so just going to be some converting back and forth. Okay, and then maybe a couple like evaluates. All right. Oh, and then of course we're going to have graphing. And I think the graphing is not going to be too bad because it's exactly the same stuff as exponentials. Just flip-flop the points. Okay, graphing with logs. Remember our exponential pattern was, okay, our main 3 in the middle here, negative 1, 1 over b, 0, 1, 1 comma b. And we know from our study of inverses in logs, or inverses of exponentials, we just flip the x and the y's. So instead of negative 1 comma 1 over b, we're going to have 1 over b comma negative 1. 0 comma 1 is now 1 comma 0. 1 comma b is b comma 1. Okay, if your base b is bigger than 1, this is what it should look like. Okay, think about, let's just pretend it was 2. All right, let's pretend it was 2. Okay, you'll have 1 over 2, comma negative 1, 1 comma 0, and 2 comma 1. Note we have this time we have a vertical asymptote. Last time with exponentials we had a horizontal asymptote on the x-axis. Now we have a vertical asymptote on the y-axis. If you have a fractional base between 0 and 1, it's going to be just basically upside down. Okay, because if you have 1 over your b, it's going to be actually a ways out here, right? And so it does look like you flip, but it's just, you don't actually flip the order. You're just going to do it normal like this. So again, let's say we have a half. Okay? Whereas 2 comma 1 put me over here. A half comma 1 is actually going to be pretty small over here. We still have our 1 comma 0. And then when I do 1 over a half, we know that flips it back up to a 2. So then we have 2 comma negative 1. All right. Let's do one here. We have log base 4 of x. Just regular old log base 4 of x. Remember our pattern we're going to do is 1 over b comma negative 1, 1 comma 0, b comma 1. What's our b number? It's 4. So we're going to have 1/4 comma negative 1. Do our best we can with that. Quiz our test. Make sure we label 1/4 comma negative 1. Then we've got 1 comma 0. Then we got 4 comma 1. Okay, so 1/4 negative 1. Do the best you can. 1 comma 0. And 2, 3, 4 comma 1. All right, we talked about this time it's going to have a vertical asymptote. So here's our asymptote on the y-axis. We didn't have to move it at all. X equals 0 there. And this is going to come down pretty sharply right along the edge there. Okay, so just like the asymptotes flip-flop, now our domain and range is going to flip-flop. Okay, now our domain is the one that gets cut because we don't go any further left than this. So my x's are greater than 0. And my range goes down forever, and it goes very slowly, it goes up, but it's going to keep going up forever. So now my y's are all real numbers. All right, there's our basic, nothing going on, just log base 4 of x. No left, right, no up, down, no nothing. But of course, we do have those still. Okay. So we still have all the good stuff there. Vertical multiplier in the front. Okay, it's going to stretch it out or flip it if it's negative. Log base b x minus h. H is going to go left and right. Okay, the minus sign is built in there, so again, this is opposite. And then the plus k on the back is going to be normal. Okay, and last time it was our back number that controlled our horizontal asymptote. This time, because we have a vertical, it's going to be tied to our inside number there. Okay, so continuing on from our log base 4 from last time. Now we have plus 3 minus 2. No multiplier. So our base ones are 1 over b. So 1 over 4, comma, negative 1. 1, comma, 0. And b, comma, 1. So 4, comma, 1. Okay, we have a plus 3 in there. We know the x's are opposite. And we have a minus 2 there, and the y's are the same. So we are going to minus 3 and then minus 2. So 1/4 minus 3, we're going to have negative 2.75. Minus 1 minus 2 is minus 3. 1 minus 3, we're going to have a negative 2 there. 0 minus 2, we got a negative 2 there. 4 minus 3, 1. 1 minus 2, negative 1. So do the best we can there. Negative 2.75, 1, 2, a little bit more there. Negative 3, 2, 3. Quiz or a test, we'd have to label that. Negative 2, negative 2. And then 1, comma, negative 1. Okay, so just continuing from this, and we just moved it over and down a little bit. Okay, so if our vertical asymptote was at x equals 0, the y-axis before, and we subtracted 3 from all of our x's, our asymptote is going to slide backwards 3. And we are now going to have our vertical asymptote at x equals negative 3. Okay, and there we go, up and over, very slowly there. Now our domains are greater than negative 3, and our range is still all real. All right, running kind of tight on time, so let's head over down to this one and see what happens with a fractional one. Remember, we got 1 over b, comma, negative 1, 1, comma, 0, and b, comma, 1 for our regular ones. This time our base is a half, so 1 over a half is actually going to be 2, negative 1, 1, comma, 0, half, comma, 1. Okay, we got a multiplier in the front. So just like before, multiplier in the front, that is going to go to the y's. Let's do that first. Y's times 3. So now it's 2, negative 3. 3 times 0 is still 0. And half, comma, 3. All right, now we don't have any horizontal change, but we do have a vertical change for a plus 1 there on the y's. So we're just going to do y plus 1s. 1, comma, 1, half, comma, 4. So we didn't have any horizontal shifting, so our asymptote should stay at 0 there. X equals 0 or on the y-axis. Okay, we got 2, comma, negative 2. 1, comma, 1. And half, comma, 4. Do the best you can with that one. This looks pretty steep, right? That looks pretty steep, but it's going to be coming down and over like that. It just looks really steep because it's got a times 2. So we're going to be coming down and flattening out kind of slowly here. Okay, So we got domains. X is greater than 0 based on our vertical asymptote. There was no horizontal shifting, so our asymptote is still there at 0. In our range, all reals. All right, folks. Do we have time to do one more? It's already a 20-minute video. I think that's going to do it for today. Best of luck there. Let me know if you guys have any questions, and we'll see you next time.